In the last video of this tutorial, we showed you how to use logic to write letters on the Pygame window. In this video, let's move further and create letters using 2 circles per letter and finish off the full animation. So for the letter M, we will need to find symmetry. So we will need 2 different circles. One will be the primary, and we will need an additional circle as well. So first, let me just define the section for the letter M, and then let me define an additional section over here. Additionals. And which will be circles underscore inner circle x1, which will be equal to, let me just do that for y as well, inner circle underscore y1, which will be equal to 0, 0 for now. And let's create an additional section inside as well. Additionals, circle inc 1, which will be equal to circle inner circle x1 and inner circle x2 y1 as well. We will also define the velocities inc underscore vel underscore 1 underscore x1, which will be equal to 0, and we will do that for the y coordinate as well, 0, like that. So now we have everything that is required to draw 2 circles for the letter M. Let's just draw them onto the screen. Pygame. In fact, let me just copy this and do it once again. Just change this to circle 3 and this to circle inc 1, like that. So now I'm going to define the positions for both the circles. For this, first I will look at the letter S, and here the ending position in terms of the x coordinate was 300 or 301, and the ending position in terms of the y coordinate was 460. So I will keep the y axis as it is, which will be 460, and in terms of x, I will give a pixel gap of 75. So the overall number is going to be 375. And for the additional circle, which is the second circle, it should be placed way off the right as well. So I'm going to add in another 250 pixels, and it will make us out to 625 and 460 as it is, like this. So now we should be able to see 2 circles, which is used to find symmetry on letter M. Let's see. And we are only able to see 1. So why is this happening? Well, it's just because we have to give in circle 2 here instead of 3. And now we should be able to see 2 circles on the screen for letter M. Yes, we do. So nice. Now for the movement, we want both the circles to go up uniformly until a set limit. And I'm going to keep the limit as 80 pixels because that is what we mentioned for the letter S as well. First, let me define for the x coordinate, circle x2 will be equal to 375, and that of y will be greater than or equal to 80. Then velocity in terms of the x coordinate 2 will be 0, and that of y will be equal to negative 0.2. And we will do that for the additional circle as well. If circle inc x1 is equal to 625, and that for the y, if it's greater than or equal to 80, then their respective velocities will be 0, and that for the y will be negative 0.2. Now we will have to define the movement. I'm just going to do it here to keep it in order. Circles x2 plus equal to velocity x2. Similarly for the y, plus equal to velocity underscore y2. And we will do that for the additional circle as well. x1 plus equal to inc velocity x1, and for the y plus equal to inc y1, like that. Now we should see both the circles to go up until the pixel limit of 80. And it does, really nice. Yep, it stops at 80. Now to make it simpler or to avoid complexity, what I'm going to do is to make respective turns such that the left circle should move this way and the right circle should move this way. So to do this, first what I will do is to make them to turn towards the respective ends, like for 5 pixels like this, and then make them to come here. For this one, it will go this way and then it will come here. So to do this, we will have to move our primary circle towards the right and then the additional circle towards the left, Before that, let me just get rid of the position saying print statement for the letter S, because we don't really need that anymore, and come here and then define for the circle x2, and it should be within a pixel limit of 375 and then 380, like this, and we will keep the y as it is. Circle underscore y2 should be less than or equal to 80. Then we want the primary circle to move towards the right, so the velocity in terms of the x coordinate will be positive 0.2, and that for the y will remain 0. We will do that for the additional circle as well, and for the additional circle it has to move towards the left, which means that we will have to define the pixel limit to be 620 to 625. Circle lines x1 less than or equal to 625, and that of circle y will be less than or equal to 80. Then in terms for the velocity, it will be negative 0.2, and that for the y will be 0, like this. So this to the human eyes wouldn't really do much, but in the background both the circles are moving to their respective ends. I'll just make sure that no errors are popping up. Yeah, it goes up and then it stops right around there. Nice. Actually, it doesn't really work for this one. We have to actually have this at this way, like this. So it should be within the pixel limit of 380 and 375, such that it is greater than 375 but less than 380. Now we should see both the circles making a sharp slight turn. It moves up and then it makes the turn. Nice. And for the final movements, we want both the circles to move diagonally until they collide. First, I want to show you how does it look like when we print the coordinates. So let's just go ahead and print it for the letter M, which is circle x2. Here. Come on, circle y2, which will be here, and see what the positions look like. And it stops at 79.8, which is lesser than 80. And now for the math, we have a pixel gap of 225 between the primary circle and the additional circle, which means that they will have to collide at the exact center, which is 125. And when we add that to the original position in terms of the x coordinate, it will be 500. So they will have to collide at the pixel point of 500. So to do this, rather than just defining it for two different circles, I will just finish it within one circle, which will be the primary circle. So if 500 is greater than or equal to circle x2, which will be greater than or equal to 380, and that for the y should be again 125 pixels, so it's 205 and should be greater than 79, because it was less than 80, so we can't give 80 over here, so we will have to give it as 79. So for the original velocities, it will be 0.2 because we are moving the left circle towards the right hand side, and that for the y will be 0.2 as well. Whereas for the additional circle, it will be negative 0.2, and for y as well, it will be negative 0.2. So right now we should see a complete M finding symmetry. And it doesn't. Okay, so the velocity y shouldn't be negative 0.2, it should be 0.2 only. But that was kind of weird, like it goes up and this comes down. Now we should be able to see both the circles colliding. And it does, nice. So we just have letter D left, and we will indulge another circle into this as well. So we are left with the final letter, which is D. And again, I'm going to use two circles, one to go up and one to make all of the curves. To do this, first I'm going to segregate all of this to make it look better. Now this looks very much better. Okay, so what I'm going to do now is to set up all the required for the letter D. We will need this one more time, so I'm just going to copy this and then paste it here and just change everything to 2. And we need this one as well. Control C, paste it here, and just change this to 2. And for the positions, I'm just going to add 75 to this like we did before and change it to 700. And both the circles in terms of the x coordinate will be 700 only. And in terms of the y coordinate, one will be 80 and one will be 460, just like that. Now let's just add in to the movements. Actually, I'm just going to copy this and then paste it here and change everything over here as well. And for the letter drawings, I'm just going to copy this and paste it here and then change everything. Okay, so I hope everything is done. Let's just run our code and see if 2 circles are visible. And yes, it is. So just the movements left off and we are done with the animation itself. Fine, so we want the additional circle to do the moving up and then the primary circle to do all the curves. So first let's just define it for the additional circle for the letter D. And over here, if circle inc x2 equal to 700 and that of the y should be greater than 80. If that's the case, then we will have to subtract it from the y coordinate until it comes to 80. So velocity in terms of inc y2 should be negative 0.2 and that for the x will be 0. So now we should see the additional circle moving up and we will be left with only 1 circle. And yes, it does. Nice. So all that's left out is for the primary circle to do all the curves. We will do that. So to do this, just like we did for the letter S, we will move the primary circle towards the right and then make a turn, come down, make a turn and finish off here. Okay, so here's what I will do. I will first add 190 pixels to this so that it moves towards the right, and then from there I will add another 35 pixels as the turning gap, and from there I will take it down and do the rest. So that it correlates to 925, which again correlates to 1000 because the 75 pixel gap, and it all correlates well. You will understand as you see the output. So what I will do is if circle x3 is greater than or equal to 700, but then it should be within 890 as well. So I will put this here. And for that, the y should be the same. So circle y3 should be 80. Then we will add velocity, positive 0.2, and that for the y will be 0. Okay, so now we should see the primary circle moving towards the right. Let's just print out the coordinates real quick. Circle 3. And yes, it does. So all that is left out is this has to make a turn, and then it should come down another turn, and then it should finish here. And when you look at this, it stops at exactly 890. So it goes greater than 890, as you see here. Again, for the turn, we want both the x coordinate and the y coordinate to move down. So we will go to letter D if I can find it. Where is it? There it is. So what we will do is if what is 35 plus 890? 925 is greater than or equal to circles x3, which is greater than or equal to 890 because it went past 890, and then for that of the circle in terms of y, it should be greater than 80, but then less than 115. So like that. We will add 0.3 pixels to both the velocity x and the y coordinate 0.3, and that of the y will be 0.3 as well. And we will define the down movement as well. So if, actually, you know what, let's just run the code and see. As it moves, and it stops right around here, and it goes past 925, and then it stops at 115.9. So both goes above 115 and 925. Now downwards, we want the y-axis to go down and x to remain static. So if circle x3 is greater than or equal to 925, and that for the y, circle y3 will be greater than or equal to, lesser than or equal to 425, because when we add another 35 pixels, it sums up to 460, which is what really we want. Circle x3 will be 0. Velocity in terms of the circle y3 should be 0.3, like that. Run a code and see. It does stop right around here, so we need to make a turn and finish off the animation itself. Now to make the turn once again, this time if 926, because it goes past 925, is greater than or equal to circle x3, which should be greater than or equal to 890. And that in terms of the y, again 35 pixels, so it should stop at 460. Y3 should be less than or equal to 460. If that is the case, then circle x3 will be negative 0.3, and that for the y will be positive 0.3. Also, I will just make it greater than 425. So now we should see the circle making the final turn. We'll run our code and see. And it does. So all that is left out is this circle to finish off the animation. I just realized that there has to be an equal to sign over here, and now we should be good to finish off the animation, which the primary circle should come to its original position, which is 700 in terms of the x coordinate. So if circle x3 is less than or equal to, greater than or equal to 700, and that for the y, circle y3 should be greater than or equal to 460. If that's the case, then velocity x3 will be negative 0.3, and that of the y should be 0. So now we should see the entire animation happening. Let's run our code and see. And it does. Beautiful. Now what I will do is I will change the color to yellow to make it look a bit contrasty to the eyes. I'll just change the color to yellow and see if that works. Yellow, actually, put that in caps. Should be equal to 255, 255, 0. And we will change all the blue colors to yellow. Okay, let's run our code and see how this color works. I guess we can increase the velocity for the letter D in the primary circle so that the animation ends up at the same time. So we'll just make it 3.5 and see if that works. Let's run our code and see. Nice, so that looks much better. So there you go, there you have the animation itself. I will have a link to this full code file in the description, and also I want you to know that this project was actually made out of a coding mistake while building a Pong game with multiple new features. I also have a video showcasing that project as well in Pygame. I recommend you to take a look at that next.